Hey everyone, my name is Monique Mazerl and I'm a fourth year nursing student working with the University of New Brunswick in St. John to create some peer-led tutorials or webinars based on MedMath. So today, this video is going to be focusing on IV flow rate. At the end of the video, we want to be able to calculate the flow rate accurately as well as convert minutes to hours, which sounds a little bit funny, but it will make more sense in my next slide here. So what is the flow rate? If you've never heard of it before, it might sound a little bit intimidating, but the flow rate is the rate that you're going to set up your IV to run, and it's a set amount per hour. So in saying that, our units for flow rate are always going to be mils per hour. Every institution uses a different IV pump, and you can also use gravity lines as well, which I'll talk a little bit more about in my next video if that's something you'd like to check out. But this one here is a plumb pump, and I just wanted to showcase that on the screen there you can read it says rate mils per hour, and that's what you would be setting in. So let's jump right into a question because I think that's the best way to explain what I'm talking about. So our order is for 500 mils of D5W over 4 hours. So what are we going to set the flow rate to? I haven't read here, let's think literally. So if the flow rate is set in mils per hour, then we can literally take the amount of mils that we have to give, which is 500, and put it over the amount of hours that we want to give it. In this case, it's 4 hours. So let's do that math out. So we have 500 mils over 4 hours. And that's going to equal 125 mils per hour. I'm not canceling anything out. These units are sticking together. So that is going to be our flow rate if that's what we would like to give, 500 mils of D5W over 4 hours. We're going to set it at 125 mils per hour. So let's move on a little bit further. I mean, that's a pretty basic question, but we're going to do a few more so that I can really stick with you guys. So the next thing that we have is we have 1,000 mils of 0.9 normal saline to be infused over 8 hours. So again, we're taking our mils and we're dividing it by the amount of hours that we want to give it. So we have 1,000 mils over 8 hours. That means that we are also going to be setting our rate to 125 mils per hour. If you think about it, the last question was half the mils and half the time, so it makes sense that the flow rate would be the same. So again, now we're going to say, okay, we want this 1,000 mil bag to be running over our entire 12-hour shift. So let's set the rate there. So we have 1,000 mils over 12 hours. We are going to set the rate at 83.3 mils per hour. And I know it says point there, but depending on the pump that you're using, you can set it to a point factor. It will make a little bit more sense when we do drip rates and gravity lines, but for now you can know that when we're doing mils per hour, we can leave it to the 10th position. Not the 100th, but the 10th position. Okay, so now we want to give 100 mils in 30 minutes. So what's the flow rate? So like, whoa, we got to hold up here. 30 minutes, that's not an hour. So the very first thing that we need to do is convert. And we have 2 ways to do this. So I'll show you the very first way. So if we want to cancel out units, we can say 30 minutes times, we know that there are 60 minutes within 1 hour. And that equals 0.5 hours. So since now we have our hours, which is what we're looking for, we can do the exact same thing that we have been doing, and that's take the amount of mils and divide it by the hours. So we have 100 mils that we want to give, and it's going to be divided by 0.5 hour. And our flow rate is going to be 200 mils per hour. The other way of doing this is just a little bit more, not simplified, but it just combines all of these steps. So you can do, if you're looking, you're going to take your 100 mils and you're going to do it just like you would normally. So you're doing 30 minutes. But again, we need to get rid of this unit. We need it in hours to be able to calculate this. So you can multiply it by 60 minutes per 1 hour. So it's the same thing. It's just combining the steps. It depends on how you like to do math. If you're good with combining it all, great. If you like to break it down, then that's great too. It's whatever works for you. But either way, you're going to get the exact same rate. It's going to be 200 mils per hour. Okay, so next up we are going to be looking at normal saline is what we're going to be giving, and we want to give 3 liters within 24 hours. So So the most important thing to remember is that our units are always in mils per hour when we're calculating the flow rate. So we have to do our little conversion here. So we know that we've got 3 liters, and within 1 liter, this is canceling out units, we have 1,000 milliliters. So we know that this 3 liters equals 3,000 mils. So this makes it easy. We can do our flow rate. So we're taking 3,000 mils and we're dividing it by 24 hours. And our calculation is going to be 125 mils per hour so that we can accurately give 3 liters within 24 hours. Okay, so it's all pretty basic, right? But there's more to it. So a little bit more complex question is we need to find out how many hours it's going to take to infuse 1.5 liters of D5 normal saline at 125 mils per hour. So let's do this math here. So the first thing that we can do, there's 2 ways to do this. We can take 1.5 liters and we can do the conversion. So we know 1 liter, 1,000 mils. And that's going to be 1,500 mils. So since we're looking for mils per hour, if we again cancel out our units, then we can find how many hours it's going to take. So we have 1,500 mils. This is running at 125 mils per hour, and that is going to equal 12 hours. So what we would do here, the units are canceling out. The other way to write this down is we know 1,500. If you're a little bit more visual, I'm a little bit more visual, so I definitely understand. So then we have 125 mils per 1 hour. So then you can just cross out your units. And again, you'll find that you are going to be running, like this is going to be running for 12 hours to get the full 1.5 liters. So the next thing that we have, again, is we have 100 mils of normal saline running at 250 mils per hour. So how long is this going to take to infuse? The best thing that we can do, again, is cancel out our units. So we have 100 mils, and we know that it's per hour, and it's 250 mils per hour, right? So we're going to cancel out those units. So that equals 0.4 of an hour. The thing with this is we don't want to leave it like this. Like, what is 0.4 of an hour? So let's figure that out. So again, units. It's like the best thing that you can do to figure this stuff out. So if you have 0.4 of an hour, you want to cancel out your hour units, and you know that it's going to be 60 minutes within 1 hour. You do that math, and you have 24 minutes. So if you pump this in, you're giving an IV piggyback, and you want to know when to come back, when it's going to be finished. Now you know that it's going to be done within 24 minutes. So this is it's pretty good math. I mean, it's basically mils per hour, and if you cancel out your units, you can figure out anything that you're looking for. That's my best advice. And next up in videos, we're going to be doing drip factor, so gravity pumps. So it gets a little bit more complex if you're interested in checking that out as well.